now that we have the basics of naming, this lesson is going to go through several different types of molecules that we can see based on their structure. So we've already looked at the names alkene and alkyne. We're kind of told what those will be about from our previous lesson. Cyclics will be something new, but continue with the same method that we've been using so far. So just a reminder, every carbon here is going to make 4 bonds. What we saw before when we were looking at alkanes is that all those bonds would be single bonds. But now that we have alkenes and alkynes, we know that we're going to have somewhere in our chain, if we're looking at alkene, a carbon-carbon double bond. And we're going to change that ane suffix to an ene. And again, if we're going to look at something with a carbon-carbon triple bond, we'll now change the suffix to an -ine because we're looking at the organic family of alkynes. So these are 2 terms that maybe have popped up to you in biology class, or when you're looking at different types of fats maybe. They're things that are going to maybe ring a bell to some people, which is unsaturated and saturated hydrocarbons. So what we saw with alkanes are saturated hydrocarbons. Every bond that a carbon had was either saturated by another atom of carbon or an atom of hydrogen. Alkenes and alkynes, however, have some bonds that are directed towards the same atom, a double bond to another carbon or a triple bond to another carbon. So they're not fully saturated bonds. We don't have as many atoms in this molecule now as we did when we were looking at alkanes. So these guys are unsaturated. We have fewer hydrogens in these. So nothing too much to take home from this slide, nothing to do with naming, just that alkanes are saturated. Once we have multi-bonds like double and triple bonds, we're looking at an unsaturated hydrocarbon. Anyways, so how do we change those naming rules when we're looking at alkenes? Just a couple of things. So we already knew that our suffix was going to change to -ene. So that's how we know if we looked at the name of a molecule that there's somehow a double bond somewhere in that. We obviously have to look at the rest of the name to figure it out, but -ene would tell us we're dealing with an alkene. Also, we were looking at some twisty branches and stuff before. Our main chain sometimes was a little bit hard to find. When we're looking at a main chain of an alkene, we know for a fact that the carbons on either side of the double bond both have to be in that main chain. Even if we can find something longer, those 2 things have to be in the main chain. And then when we're numbering stuff, like how we were numbering to find out where the methyl and ethyl groups were in our last lesson, now we want to number in a way that makes that double bond as low as possible. So maybe even if we have stuff really close to one end, a bunch of bromos and a bunch of methyls, if that double bond is closer to the other end of the molecule, we're going to start our numbering closest to the double bond end. Anyways, so let's see how we change these rules to name this guy. So we have in this box, it's hard to see with all the dashes, that's just one single bond, I'm sorry. We know this is our double bond, making it an -ene, making it an alkene. This has to be part of the main chain. So I say that because our longest main chain, if this were an alkane, would be kind of this horseshoe, right? We can make 6 carbons long. However, if we were to do that, we wouldn't have this carbon, which is part of the double bond. That is one of the rules, right? So we can't do that anymore. We have to make sure both of these carbons are part of our main chain, and then we'll try to extend it as long as possible. So this would be starting here with my highlighter, keep going. Obviously I'm going to keep going straight instead of going down, keep going straight. Now I want to bend down because I can get 2 extra carbons instead of just the 1 if I continue to the right. So the pentene comes from the fact that there's 1, 2, 3, 4, 5 carbons. Cool. So we can number that main chain now, even without looking at this stuff, because we know we want to make these carbons as low as possible. So we know this would be carbon 1, 2, 3, 4, 5, instead of backwards, because we want to make this double bond take precedence in the numbering. So that's where that 1 comes from. We always put the number of the lower carbon in the double bond. So obviously carbon 1 and carbon 2 are participating in this double bond. We only need one number though. So we'll say the lower of the two numbers. The double bond starts at carbon 1. We've got a carbon 2 with some stuff coming off of it. It is 2 carbons long. If we went back to that chart from the last lesson, we'd know 2 carbon long alkyl or branch is called an ethyl. So there's our 2 ethyl. And on the third carbon, we just have a single carbon branch. So that is a methyl, and we'd get a 3-methyl, named in alphabetical order, ethyl before methyl. All glued together using the same rules as before, dashes between numbers and letters, didn't need any commas, and no spaces. So that quickly moved us through the alkenes. Alkynes are named just like alkenes, except now we have a triple bond and we want to change that suffix to YNE. Both of these are kind of simple. So we've got 4 carbons in a row. 4 carbons would be that bute prefix. Ine, meaning we have that triple bond here. We need to number where the triple bond is. We can start actually on either side because you can probably tell that's symmetrical. So we'll start here, 1, 2, 3, 4. So we use the lower number of the bond. Or if we want to go backwards, 1, 2, 3, 4. So either way you number it, we'll end up with a 2-butene. Here we have a triple bond right here, a chloro all the way on the other end. If this were an alkane, we would definitely make this carbon 1, right? Because we've got something right on carbon 1. However, because we have a triple bond, we know this would have to be the first carbon in our chain because it's the H doesn't count, right? This would be carbon 1, 2, 3, 4. 4 carbons long again, so we have a butene. The carbon triple bond, though, is in between 1 and 2 now, so we use the lower of the 2 numbers and call it a 1-butene. And that chlorine is sticking off of the last carbon, carbon 4. It's a 4-chloro, 1-butene. So that quickly got us through alkenes and alkynes. The new stuff is cyclics compounds. So that's when we take the chains we've been looking at and they kind of fold in on themselves. So this end and this end would end up folding in and bonding with each other. And we'd make a shape. So if we have something triangular, 3 points, there's a carbon at each point, we have something called a cyclopropane. We put a prefix called cyclo when we're naming these things. If we have 4 points, we now have 4 carbons. We have a cyclobutane, bute being 4 carbons. We can also have cyclics that have double bonds in them. So we have 5 carbons, 5 points to this chain. We have a cyclopentene. And when we get into how to name these, you could write a 1 here if you want. We'll see the rules for naming this. So this could be a 1-cyclopentene if you wanted to, or leave it at just cyclopentene. Okay, cyclics. That made it look easy. Cyclics can be some of the hardest ones based on what's coming off of them. So a slightly different naming rule, because now we don't have a clear start and end to our chain, right? It's kind of cyclical, a circle. We could call any of those carbons carbon 1. So if we did have branches, what we're looking for is the lowest combination of numbers. And we'll see that in some examples. And if we have a double bond in the chain, just like when we wanted to make it the lowest number when we were looking at chains, sorry, if we have a double bond in the ring, we will automatically just make those the lowest numbers we possibly can. So if we have one double bond, we'd make it carbons 1 and 2. Okay, so this guy obviously has a double bond. So I made it sound simpler than it really is. Here's our double bond, so we know we're going to have carbons 1 and 2, but there's a secondary idea here that we could name it 1, 2 and go counterclockwise, or go 1, 2 and go clockwise. So there's a secondary rule that, yes, this is going to be 1 and 2, but let's also number them as 1 and 2 in a way to make this alkyl group as low as possible. So if we did it 1, 2, 3 versus 1, 2, 3, 4, 5, and have to wait all the way to the 5th carbon, we're going to go with option A, the first one I did. So 1, 2, 3. That's why we've got a 3-ethyl. Cyclo telling us that we've got it coming off of a shape of a pentene. You can, as I said, right here put like a -1 between ethyl and cyclo, but because it's one of those rules that we're going to make this double bond as low as possible, if I were to see cyclopentene ene telling me there's a double bond, I would just presume that double bond is between 1 and 2. Okay, so a double bond again, and we've got 2 branches this time. Okay, so here's our double bond. We know these are going to be carbons 1 and 2. We just need to figure out which direction we want to number them. So that might be where the combination comes in. So remember that we want the branches to be the lowest combination possible. So let's do, I'm going to call this 1, 2. So this was a 2-methyl, 3, 4, 5, 6-methyl. So if that's a 2 and that's a 6, the combination is 8. We're just going to add them together. If we go in a clockwise direction, we have a 1-methyl, 2, 3-methyl, a 1 plus a 3, 4. It's a lower combination. So when we're numbering, let's make this a 1-methyl and a 3-methyl, so a 1,3 dimethyl cyclohexene. Hex because there's 6 carbons, ene for this double bond. Our answer is right here. We can put in that 1 there if it makes you feel a little more comfortable labeling absolutely everything. It wouldn't be wrong, but it isn't essential to put that in there. If you're like me, it's pretty hard actually to draw basic shapes. So instead of actually drawing out all the carbons at all the points, because we know there's going to be a carbon at each of these points, we can honestly just draw shapes instead. So we'd know there's a carbon at each of these points. We don't actually have to write it. So this would be a cyclobutene, because bute being 4. Ane, because we're back to having no double bonds. This guy does have a double bond. We've kind of made a pentagon. 5 points, 5 carbons, so pent. And we've named it ene because of the double bond. We could put 1 cyclopentene if it makes you feel more comfortable, but totally not necessary. This guy is a hexagon, 6 points, hex for the 6 carbons we have here. Cyclohexane would be the whole shape, and we've got 3 methyls popping up. Obviously, they're all in a row, and we want to give them the lowest numbers possible, so why not just call them 1, 2, 3 trimethyl. This won't come up too often. If you were to have perhaps a test, it could be like kind of that multiple choice type question for determining general formulas. So one place you could check to see these answers quite easily would be the charts from the last lesson, where it shows us all the alkanes. So there's a way, if there's no branches or alkyl groups coming off of an alkane, alkyne, and cycloalkanes, to find out how many hydrogens it would have. And that would be Cn And then, so N being how many carbons there are. And then twice that many carbons plus 2 to find what the general formula for an alkane would be. So check that using that chart from the last lesson, and it should all add up. If we're then looking at alkenes and cycloalkanes, they'll have 2 fewer hydrogens. And that's just because of that double bond needed between 2 of the carbons instead of being between 2 separate hydrogens, or because the main chain has to fold in on itself so that the terminal ends of a chain have to get rid of a hydrogen each in order to bond to each other and make that shape. And then if we've got another multi-bond, a triple bond, we're going to even have 2 fewer carbons. So it would be a -2 for this guy. So not something that will really pop up for us, but a cool bit of information to have.